Now talking about 5G NR, the access technology that is used between the GNB and the user equipment on the wireless interface or the air interface, it is OFDMA. And we know very well that OFDMA stands for orthogonal frequency division multiple access, and this is the same technology that was used in the 4G LTE, but there are some significant differences that we must understand. We know that in the OFDMA, the frequency band that is in a cell is divided into orthogonal subcarriers. For example, here in the red color we have subcarrier, one subcarrier. In green color we have another subcarrier. In blue color we have another subcarrier. And when we have the peak of a subcarrier, the other subcarriers have the zero value, and this is the frequency axis. So and the spacing between two subcarriers is called as the delta F. And in the case of LTE, this subcarrier spacing was 15 kilohertz. Now we know that 5G NR operates over a much wider range of frequencies. So as the frequency increases, then we have the problem of interfrequency interference. That is because of the Doppler shift and the phase error in the oscillator of the receiver. What happens that this orthogonality condition may be disturbed. This means that the other subcarriers do not have their zero value at this point. So as the frequency increases, you have the Doppler shift effect that affects the frequency, and you have also the phase error due to the difference in the phase of the oscillators of the transmitter and the receiver. So even smaller phase error can have a very big impact. So in order to solve this problem, because when there is no orthogonality, then there are interfrequency interference and there are bit errors, and this problem is very aggravated at the high frequencies. So the solution to this problem is to use scalable carrier spacing, and the other name of the scalable carrier spacing is also flexible numerology. And the flexible numerology is characterized by the factor mu. For example, when mu is equal to 0, we have the 15 kilohertz carrier spacing between the subcarriers, between the adjacent subcarriers. And when we have mu is equal to 1, this carrier spacing doubles, because when we put mu is equal to 1 here, we have the delta F of 30 kilohertz. And when mu is equal to 2, we have the subcarrier spacing of 60 kilohertz. So for higher frequencies, we use higher carrier spacing, means we use higher value of mu, and this is called as the flexible numerology. And also there is another thing, that is cyclic prefix. So if we see in the time domain, for example, this is one OFDMA symbol, this is another OFDMA symbol, this is another OFDMA symbol, and this is the time domain. So this guard period between two symbols is known as the cyclic prefix. And the purpose of this guard period is that so that one symbol does not overlap with the adjacent symbol, especially in the multipath environment when you have the reflections from other buildings, etc. So there are two prefixes. One is the normal prefix and one is the extended prefix. Extended prefix is especially useful in the cells which have a large area, because there will be more bouncing back of the signal from the buildings and more multipath effect in the large cells. And so we use the extended cyclic prefix in that case. Now in the case of 5G NR, the time is divided into the frames of 10 millisecond, and each of these frames is then divided into 10 subframes, and one subframe has a time of 1 millisecond. The duration of one subframe is 1 millisecond. And if we take one subframe, and if we are using the normal cyclic prefix and the subcarrier spacing is 15 kilohertz, then one subframe will have one slot of 14 symbols. Now if we move from 15 to 30 kilohertz, we know that the time and frequency have inverse relationship. When we are increasing the subcarrier spacing, the time a slot will be occupying will reduce. If we are doubling the subcarrier spacing, in that case the time that is occupied by a slot will become half. So here for 30 kilohertz we have two slots of 14 symbols each, and if we again double the subcarrier spacing from 30 to 60 kilohertz, in that case the time of slot will further reduce, and in this case we have 4 slots in a subframe. And when we move to 120 kilohertz, in that case we have 8 slots in that case. So one slot is always equal to 14 OFDM symbols or OFDMA symbols when we are using the normal cyclic prefix. And if we are not using the normal cyclic prefix, then in that case we are using the, if we are using the extended cyclic prefix, then we have the one slot will be equal to 14 OFDMA symbols.